Hello again. Our next talk will be in English, and Alper came from Turkey to speak. So Alper, it's your second .next.
Yes.
First time you were here in 2019.
Yes.
How do you feel?
Yes, after 6 years, it's very happy to be here as a speaker. Today we are going to talk about multi-tenancy actually, and I will try to explain my experiences about how I face the real-world multi-tenancy problems and how we solve in a framework level.
Окей. Друзья, я напоминаю, что у нас есть QR-код, который можно отсканировать и задавать вопросы. Если у вас есть проблемы с переводом на английский, можно задать на русском, и мы их потом переведем. So, let's start.
Okay. Welcome to the session. I think you are tired a little bit. This is the last day. I'm Alper. I'm coming from Turkey, and I'm co-founder of Volosoft, which is producing open source frameworks, tools, and commercial products. Let's first start about myself. I started in 1997 with QBasic, which is very low-level Microsoft DOS-level programming language in i386 processor, Intel processor. And I got this screenshot today, this one. My first .NET application. It's still online on this website. And 20 years ago, I wrote this application on .NET Framework first version, 1.0. It's like you put your files inside and you lock. Nobody can delete. It's not seeing anything inside. It's like folder lock. I finished my university in 2006, computer science. Later, I finished master degree on business administration. And now we are running a company called Volosoft. And my company is building, first we started our life with ASP.NET boilerplate. And on the right side, you can see I'm still contributing to open source repositories. And at the same time, managing team and architectural decisions. Now, ASP.NET boilerplate, it's multi-tenant application web framework, and we started in 2013. And now it's under the umbrella of .NET Foundation. But it's monolithic application. That's why we started another open source web framework, which is on top of ASP.NET Core. And this framework is also multi-tenant framework. So when you start a new application on top of this framework, you will have microservice compatible, multi-tenant enabled, and many generic functions, features are already implemented in this framework. And it's open source, 12K stars on GitHub. We are regularly releasing new versions. You can see it's very popular on NuGet, 27 million downloads. I'm showing this because we have a good experience of modular application development, microservice architecture, DDD, and multi-tenancy. And in the next slides, I will show you how we solved real-world multi-tenancy problems and issues. First, I will going to explain some overall information, descriptions about multi-tenancy, the advantages, hardness of building multi-tenant applications, and different application database deployment scenarios. Later, I will explain how to identify a request tenant ID, and when you need to change tenant, how to do this in code, and how to isolate data logically or physically. And sometimes for reports, background services, you need to conditionally turn on or off multi-tenancy. And I will show you how to do this practically. Another problem of multi-tenancy is database migrations, because whenever you update your application to the latest versions, if you have different databases, separate databases, you need to also upgrade all of them at the same time or scheduled way. So you need to deal with this problem also. I will show you the problem and solutions we make in this framework. And if we have time, I want to tell if all we need multi-tenancy or not. Because sometimes I'm getting questions about, I have like this architecture, do I need multi-tenancy? Or people do multi-tenancy without need. Let's start with the description. Multi-tenancy actually approach to build SaaS applications, software as a service applications. And in this model, resources are shared between the tenants. So you can share them logically, virtually, or physically. So the purpose here to share our resources and maximize the number of our customers. Otherwise, it's hard to make multi-tenant applications. So we are trying to do this for minimizing our costs. And in this architecture, our clients, customers who are using the service, they are called tenants. And we, or service provider who is organizing this service, it's called host. And don't forget, an ideal multi-tenant application should be unaware of multi-tenancy as much as possible. I'm not telling perfectly you can do this, but when you write code in your application services, repositories, domain services, you shouldn't write every time tenant ID equals to this active tenant, or send parameters in URLs like tenant ID is this. Application shouldn't know about this. All these multi-tenant features, functions, should be implemented in a core level. Like you need to create a core framework, like ABP framework, or you can create your own framework, and do this in your core level. It will also help you to avoid human mistakes. Like when a junior developer joins your team, he may forget tenant ID filter. So these needs to be done in framework level. Also, whenever your customer wants to deploy this application to their environment on-premise, it should also be deployable. So this is the ideal multi-tenant application definition. And there are different service models in SaaS applications. On the first one, you see on-premise. So you are going to deal with your application, database, middlewares, even electricity, networking. So this is called on-premise, and it's not SaaS friendly. The second one is infrastructure as a service. Google Compute Engine, Azure Virtual Machines, these are infrastructure as a service. And in this model, you don't deal with networking, computer management, RAM updates. These are handled by your service, which you are buying service. And you need to deal with upgrading operating system, install your ASP.NET Core, middlewares, runtimes, or SQL Management Studio. You need to deal with this. In the third one, you just deal with your application and database. Other things are handled by your service provider. So platform as a service can be exampled like Azure App Service. It's platform as a service. Also Google App Engine, Heroku. These are platform as a service systems. And fourth, software as a service. You don't deal with anything. Like Discord, Zoom, Gmail. Whenever a new tenant comes, they just insert a new line to their tenant's record. So you don't deal with any computer management system. Actually, multi-tenant applications have very much advantages, but let's count 5 of them. First, we do this for cost efficiency, because you are sharing the hardware and software resources among your customers. You reduce costs and serve the maximum number of clients. So this is maximum utilization. Second, all of our customers use the latest version. We know this. And we, as developers, focus on maintaining a single code base. Imagine you install your application, all your customers on-premise. You need to deal with different versions of your customers' software. Third, ease of maintenance. So maintaining a single code base for us, for developers, it's easy. Because when you patch, when you make bug fixes, all your customers will benefit from this. So easier for developers and administrators to maintain the system. And as a fourth, scalability. So when there is a demand spike, like Black Friday days, you can easily increase the server resources and you can give a better experience to your customers. Otherwise, imagine you have 10 customers and in Black Friday, you need to upgrade their system at the same time. It will be not very possible. And rapid deployment for new users. It means when a tenant joins your system, you just need to insert a new line to your tenants table, and that's it. You don't need to set up each time to your customers. So these are benefits of multi-tenancy. On the other hand, there are some challenges. Why shouldn't we do multi-tenancy? First, if you cannot properly isolate data between your tenants, unauthorized access can be sent to the sensitive information. So it's very important to isolate data. If a junior developer forgets tenant ID filter, it means all the tenants will see each of their data. So we cannot make such big mistakes in this. You need to be very aware that you need to add every time this tenant ID thing to your repository methods. Second, your customers will not want to use the same look and feel of your application. Imagine you have Nike and Adidas as your customer for your tenant, multi-tenant application. They will not use the same color. They will try to customize their login page. They will change the logo. Or maybe Nike will want to put a menu to the top and Adidas will want on the left side. Or they will need to rebrand all these color schema. So it's important. It's not easy to make multi-tenant applications. It should be very configurable to your customers. They can go to a setup screen and change everything what they see on screen. So it's hard, a little bit hard. Also, imagine you have hundreds of tenants. Not all the tenants will use the system at the same balance. Maybe one of your tenants will always generate reports, run queries, heavy operations. We call these guys noisy neighbors. They will affect the other tenants. So if you leave them alone, your system will be slower and you will not understand who is making this slowness. So you need to keep an eye on the monitoring screen. You need to create rate limiting rules. So they will not extensively use the system to disturb your other tenants, or you ask more money. Fourth, security. Imagine you have a security hole. No one do this on purpose, but it can be like this. When a hacker gets into your system, he can steal all your data, all the tenants' data, and gain access to all your tenants. But if you install your application to on-premise, if a hacker gets into the system, he can steal just this tenant's data. So it's also important because you are holding all your tenants' data. You need to be very careful on security issues. Another thing, backup and recovery. So if you are giving this service as a shared database, like hundreds of tenants are in the same database, when they want to back up their data, what you will do? all their data is spread into different tables. You need to write queries which will gather information from different tables, and you need to generate a dump file, and he will download this, and this dump file also needs to be recoverable. When he needs to recover this data. It's not like in SQL Management Studio, you backup, make backup file, and restore. Because one customer asking this backup data, also you need to give them this opportunity. And sometimes banks, government agencies doesn't want to hold their customer data all forever. Sometimes it's called data retention policy. They will say you, keep my customer's data last 3 months and delete the logs. So you should also give this service as a multi-tenant application developer. These are challenges, hard sides of multi-tenancy. And as you see here, 4 different types. First one is not very multi-tenant friendly way, because you install your application and database to the customer's environment. Second one, I will use, okay. In this model, you see there is a single application instance. Everyone is using our application server, but each customer has their own database. So when you think it's very good, it will be very performant, but as a multi-tenant developer, it's not very profitable, because you need to deal with these dedicated database, upgrade these database always. So imagine you upgrade your application server, what you will do, you need to update all these databases at the same time, otherwise it will not work. In the third one, I think this is the best multi-tenant friendly way, because one application instance and one database, everyone is using this setup. It's good, but imagine if one of these customers have a lot of data and they want you to separate their database, you cannot do this in this solution. And always hybrid solutions are best. In the fourth way, you are giving a shared database to the customers, and if they pay more, you can separate their databases. So for overall, you can think, if you make a hybrid solution in your database and application architecture, it will be the best one. Maintaining application state is also another issue. I'm accepting that you are using all web applications in this model, and you are using HTTP, and you know HTTP is stateless protocol. This means user data is not persisted from one page to the next. So a stateless application doesn't save any data on the client side. So you cannot save your tenant ID value on the client side. So our multi-tenant application should also be stateless. Besides, the stateless approach is multi-thread friendly. So where we should save these states? You can save your tenant ID in the cookies, in header, or query string, or payload, or in GVT tokens, authentication ticket, or you can save them in database, or like Redis, Memcache, these are distributed caches, you can save it here. Okay, until now, I gave you some general information about multi-tenancy. Now I will show you code, but simple codes, which I retrieved from ABP framework, this open source framework, and I make little bit simpler versions for you to understand and focus what I'm telling. So if you are interested in the whole solution, you can check out the framework's repository. First of all, when we get a request from server, we need to identify which tenant's user is making this request. This is our first problem for multi-tenancy. And in our framework, we have created 6 different ways to understand tenant ID, and these are fallbacks of each other. Let's start one by one. First, claims. When a user logs into the system, you know its tenant ID, and you can save the tenant ID in the claims. As you know, ASP.NET Core gives, like here, HTTP context user identity claims. This is a collection. You can save this tenant ID in the claims, and when the user is authenticated, you can just get it from this collection. And in the framework, we do like this. We created an object for current user, and we are injecting this by the help of dependency injection, iCurrentUser. And on the current user object, you can get tenant ID, and the implementation is here. Second, if you cannot understand from the claims, you can check the URL parameter here. You can give all tenants name, GUID, or ID like this. And I simplified also this code. And in ASP.NET Core, HTTP context request query, it's a collection of query parameters. You can easily get tenant ID. If it's not null, then set. Next, you didn't still find tenant ID. You can use roots here. As you see, ACME is our tenant ID. And we are using tenancy name as tenant ID. And we can easily get root value from HTTP context and set. Another fallback, request header. Especially we are using request headers in single page applications and mobile applications. It's the best way to store tenant ID for SPA and mobile applications. And in the downside, this section, client is sending its tenant ID like this in request headers, and we can easily read this in ASP.NET Core and set like this. Cookie is another way. If you still didn't find tenant ID, you can use cookies as a fallback and read the tenant ID from cookie value. And last, you can use subdomains. I like this solution because if you are creating some e-commerce websites, you can give adidas.onlineshop.com, nike.onlineshop.com, and just write a simple parse regular expression query to read this area, and this is your tenant ID. So these are all fallback of each other. So we understand how to read the active tenant. Let's see, we have tenant ID now. Let's see how we can isolate this data. Normally, when you have a tenant ID and when you create a multi-tenant bookstore application, you need to do like this. You have tenant ID, you read this tenant ID from the active scope, and you get. And this is books repository and books table. You need to include this link queue expression and filter. It's very easy, but it's very open to developer mistake. Whenever you forget this tenant ID, all the books will be retrieved from database. Or when you have big queries, every time you need to include tenant ID, and it makes a little bit complicated. So let's see how we do this in a framework level. I will try to explain how to make it standard. So we have created an iMultiTenant interface. So we are using this iMultiTenant interface if we want to make an entity multi-tenant. It's simple interface. It's only tenant ID, nullable GUID tenant ID property inside. And If my book entity is multi-tenant, I just need to add this, and it's adding a standard tenant ID property. I'm doing so because I want to make it standard, because I will use now reflection methods to every time set and read these values from multi-tenant entities. I take this screenshot from EF Core's official documentation from Microsoft. In EF Core, Entity Framework Core, there is a feature called Global Query Filters. And it's life-saving feature to make a multi-tenant application, because it's giving us automatically global queries filtered in EF Core. No need to do this every time in your application, tenant ID equals active tenant. Even Microsoft says you can use this feature in multi-tenant applications. Like you can add tenant ID, I will automatically filter this. Or imagine you want to use soft delete, not physically delete data. You can add is deleted to your entity, and EF Core will automatically bring is deleted false entities. So let's see how we use this in a framework level. This is how Microsoft suggests us to use this. It's the usage. You see, it's DB context. I derived from Microsoft's EF Core DB context, and I have my books here as a DB set, and I'm overriding the EF Core's on model creating method, and I say my book entity needs to be filtered with the active tenant ID, and I'm adding this filter. So every time I use book repository, it will automatically add this query, link you expression to my queries. No need to write again and again. I write one line in DB context, this rule, and it will be always filtered. So every time you need to make an entity multi-tenant, you need to write this in the DB context. But let's not write always like this. Let's also make it standard in a framework. Now, this is how we make standard. This is also DB context, but this time we are creating our own DB context, and we call it ABP context. You can create your own. And you see here, we are using a reflection method, and we are scanning all the application which implements iMultiTenant interface. And if entity is iMultiTenant, I'm creating this link query expression which EF Core likes on the fly, and I add has query filter which EF Core wants me here, has query filter, and I'm adding this filter automatically to all multi-tenant entities. So no need to write the EF Core's rule every time. If I write iMultiTenant to an entity, it will be automatically here. This is first step, how we automize this. This approach is very good because it's very easy to implement. I show you simple lines of code, which you do this, and all your entities will be automatically filtered by EF Core. It's also supporting navigation properties. It's also very good. But you are stick to EF Core, don't forget. If you want to use NoSQL databases like MongoDB or other things, Alper, it will not work. This solution works with EF Core. Another disadvantage of this solution, EF Core gives us a method, ignore query filters. It's very good because when you want to disable filter, it disables filters, but at the same time, it disables all filters. If my book entity is deleted and tenant ID filters. When I do this, both filters will be disabled. So I will bring all the books, which is from different tenants, and also delete it. This is one disadvantage. Another disadvantage is animal is the root entity, as you see here. Big animal, small animal, inherit from animal. You can just define this rule to the animal class. You cannot define to derived classes. Another disadvantage of this solution, if you want to use TSQLs, I think nowadays nobody is using, but if you have a business logic like this, you want to use stored procedures, raw SQL queries like this, this is not supported. If you write like this, tenant ID filter will not be included in your queries. Okay, for all these disadvantages, Microsoft suggests us another feature. It's called row-level security. I take the screenshot from EF course documentation again. Here, data isolation is handled in the database level. But remember, it's for SQL Server, Azure SQL Server. If you want to use Oracle, MongoDB, then it will not be supported. Row-level security is giving us an opportunity to define global filtering to the connection. So no need to write EF course coding rules. Even you open SQL Management Studio and write queries like select star from books, it will be automatically filtered by your user. If you are a member of a tenant, only your books will be retrieved. I think it's also a nice feature, but you are stick to SQL Server. And if you want to, if you have a plan to change SQL Server to Oracle, you need to implement multi-tenancy again in your application. So I think this EF course solution, global query filters, is the pragmatic and easy way. I will choose this one, not row-level security. If you are using MongoDB, which is not supported by EF Core, you are using MongoDB drivers in your ASP.NET Core application, what you will do, you can implement your own global query filter. It's not very hard. You see here, we created a filter definition here, and like I showed you before, I'm checking if my entity is implementing MultiTenant interface. If yes, I'm creating a new link queue expression on the fly and adding a global query filter. This is my own filter, which is globally defined in application. And each time I use my own MongoDB repository method, I will add this filter automatically to my queries. And this is how we solve in the framework if developers want to use MongoDB. Okay, until now we learned how to identify active tenant and how to isolate data. So let's see how to set tenant ID for new entities. You can ask why I need to set tenant ID for new entities. I can do like when I create new entity, like new book, I can set tenant ID. I can get the tenant ID from active scope and set. What's the problem here? Problem, developers can forget this. So to avoid human mistakes, let's try to see how we do this in framework level, how we automatically set tenant ID. I make a simplification in our tenant entity so that you can easily understand. This is the basic class of my entity, which needs to be interacted with database. And in the constructor, I'm checking first if it's an MultiTenant entity. If it implements MultiTenant entity, I will continue. If not, no need to continue here. Here, I'm getting tenant ID from active scope from this instance. And with the help of reflection, I know that I have tenant ID in this iMultiTenant interface. I can easily set this. So you see, no need to set tenant ID every time you create. This code will ensure each time a new entity is created, it will automatically set tenant ID. So we will not make any mistakes as a developer or newcomers to the team. Identifying active tenant, data isolation, setting tenant ID. Now let's see how we will choose DB connection string. If you have only one DB connection, if you are using only one master database, it's not a problem. Just use this default connection string. But normally, you will have one database shared with several tenants, and you will have dedicated databases also. Who pays more? We say we will separate their database, or if their data is much more than others. So, in this framework, we have created a database table, tenant connection strings. In this table, we are holding all our tenants' connection string. And it's very easy. Tenant ID, name, and connection string. This connection string can be anything, like PostgreSQL, Oracle, any other thing EF Core supports. So when your application allows customers choose their own database, you will save their database connection string in this table. And if they are using shared database, you can use the connection string in your app setting JSON files or configuration places. And you can even give, if you are using a microservice environment and each service has their own database, you can even separate microservices databases. Like you have a big application, CRM and HR is in the same application. CRM can be Oracle, HR can be Microsoft SQL Server. Now I will show you how to do this in the real-world code. I created a default connection string resolver, and in EF Core, there is a class, DB Context Options Builder. This class let me identify my connection string each time I resolve DB context. So whenever a request try to make database interaction, a new DB context is creating with the help of DB Context Options Builder, and this class gets connection string. So each DB context can have separate database connection string. And in the resolve method, I check my tenant. If it's in the connection strings table, I'm using his dedicated database connection string to resolve. If not, I'm using our shared master database. So this is overall how I manage different connection strings for different tenants. But sometimes you need to change the active tenant. You can say, why? It's what's written in the request, active tenant. I will use this, why I need. Imagine you want to create reports or background services. Your application is expecting tenant ID every time, and there is no tenant. There is no request, actually. You are generating report for all tenants and maybe send email to these, like cumulative sale reports to each tenant. And this time you need to change the active tenant. You will loop your tenants, and each time you will change tenant, generate report, send by email, go to the next tenant. I will show you how to do this when you have a multi-tenant application. First, let's see the usage. My boss wants me to create a tenant statistics report, and I need to query the tenants in their own scope. You see, current tenant change. When I write this in this using block, all the queries will be filtered by this tenant ID. So it allows us to switch tenants whenever we want in our application services. Let's see how we do this. We created a change method on the current tenant object. It gets tenant ID. Also, you can optionally give tenancy name. First, we are holding the current tenant. So after using block finishes, we will revert back to the original tenant. Here, I'm holding this in a temporary variable. Later, I'm using dispose action of C#, which allows me to use using block. So if you use dispose action, developers will use it in using, and it will be more safe to run the queries in this block. And here, I change active tenant. All the code inside this block will be filtered by this tenant. After dispose action finishes, I'm reverting back to the original tenant. And I'm using this method also in my middleware, multi-tenancy middleware. So multi-tenancy is just middleware. If your application is multi-tenant, you can add this middleware. I created my own multi-tenancy middleware. And inside, I'm using this change method, which I show you here. So my application automatically becomes multi-tenant now, because I'm starting tenant filtering here with the first request invoke, and all the operations and database queries will be automatically filtered inside. And after using block finishes, it will finish the global query filter and other filterings. So you can use this multi-tenancy filter middleware like this. Another thing is sometimes you need to disable multi-tenancy. Let me a little bit. So sometimes you need to query on all your tenants, not for specific tenant, because you want to get some reports or you want to get some cumulative number on all your tenants. So to do this, I'm using a disable method, because I said you in EF Core doesn't allow me to specifically disable one of my filters. Imagine you have soft delete filter, multi-tenancy filter. EF Core doesn't allow me, so I'm creating my own procedure to disable only one filter, multi-tenant filter. So in this code block, I'm disabling multi-tenancy, and book repository get count will return me all the books count without multi-tenant ID filtering. Let's see how we can do this in code. For this implementation, I'm creating a singleton dependency data filter object, and all my filters, soft delete filter, multi-tenancy filter, is book published filter, whatever filter, I'm holding this in a concurrent dictionary, in a read-only concurrent dictionary here in filters. And all my filter has a Boolean flag, is enabled. So when this code runs, disable method, I'm setting is enabled filter of my filter object to false, and all my queries which will run now will check this Boolean filter. And if it's not enabled, we will not add EF Core's global query filters to our queries. So we can use this switch to turn off or turn on multi-tenancy. Also, we have enable method, which is setting is enabled field to true. So as you see, I'm also using disposable here so that developers can use it in using block. So not to make any mistake, when the using block finishes, it will return back to multi-tenant environment again. Another problem here, database migration. I'm trying to mention different multi-tenancy issues. And when you finished all these multi-tenancy topics, you will deal with database migration. What is this problem? I will show you. First, imagine you have a single database and all your tenants have shared database. When you deploy your application to the latest version on the application server, okay, your application instance is now running the latest version. But what if your application changed database schema? Like you added a new database column, or you removed one column, or you modified some data. You are expecting new format in the new application, but your tenants' databases are old now. Whenever you update your application server, you need to quickly update all your databases, otherwise it will not be synchronized and you will have database exceptions, like column is missing in this table, blah, blah. So it's hard topic. For this, you can create, first thing, a .NET tool which upgrades all your tenant data. But imagine if one of your tenant has very much data inside their database table, everyone will wait until it's get updated. So even your small customers, which has small data, they will wait until the big database updated. So it's not very efficient. You will wait your other customers. So I'm skipping approach 1. Let's see approach 2. In approach 2, imagine you start database migration whenever your user starts a database interaction. Like you upgrade your application server, but still tenant's database not updated, but he's trying to log into the system. This time you are initiating the database migration. And this first customer will wait until you upgrade their database. So when you think it's efficient, because as long as they will not use the system, their database will not be updated. But the first guy may face database timeout exceptions if he has a lot of data in their database. And it's really hard to implement this second approach, because when same users from the same tenant, different users make this request, you need to deal with race condition. You need to suspend first request, later upgrade database in the background, and when it's upgraded, you need to release the response to the client. So approach 3 is the ideal way for me. In this approach, imagine you have a new application server. Databases are still old from the previous version. You are doing like this. You make two different environments. New application server, old application server. Version 7, version 8. Version 7 databases are also version 7. But by the time you are upgrading customers' database to version 8, and you have a new environment, new database setup and application server. And you put a load balancer in front of these two different environments. When a request comes, you check its tenant ID. If this tenant database is migrated, you route this request to the new server. So he will use the new application UI database. And when a customer comes and still not upgraded its database to the new version, you will use load balancer again to route this request to the old environment. Everyone will use healthy in this solution. And by the time you will upgrade your legacy databases, no one will see any stop in their process. But in this solution, it's a little bit hard to maintain two different environments because now you have identical two different application setups, and you are monitoring these. More DevOps efforts need, but at the same time you can run A/B tests because new version is running now, and you are getting new logs. At the same time, you can see the bugs before anyone. And I remember Gmail do this 10 years ago. Maybe you also remember when Gmail renovated their UI, some people using old Gmail, some people using new Gmail. How it comes? I'm logging in the same Gmail, gmail.com. I see old version, my friend sees new version. It means Gmail is also doing this solution. It's checking my user ID. If my user database is upgraded, it's redirecting me to the new environment. And while my friend using the new UI, I get a notification on top of the Gmail. It says they will update my UI in the upcoming weeks. It means I'm scheduled now. So if you have a very big system, this is the ideal solution. Let's see feature management, because multi-tenancy, this is also a topic of multi-tenancy. I'm giving example from a known system, Netflix, and this is really from Netflix website. They have HD available feature. These are features, and these are their subscription plans. And you see HD available is not active for basic subscription. Imagine you have a multi-tenant system like this, and you are trying to achieve this in your application. First, if you search Google feature management, you will find this library from Microsoft. Even it's not from Microsoft, it's from Azure team. Azure team created this package. It has nothing to do with feature management. It's for A/B test. First of all, we also fall in the same problems. You can use this library to check a Boolean value in your application. Like you added a new banner and you are making A/B tests. Some of my users will see this banner, some of I don't want, they will see this. You can use and test if you create new banner and performance is good. So I'm skipping this solution, and we created our own solution, custom solution. As you see here in define, I can group features like video feature, and is HD available is my feature. So these features, all these features, as you see here in Netflix, we hold these features in feature definition class. It's a simple class. It's a dictionary class with a singleton dependency. And I can use this class to check my features like this. You see, it's a declarative check. I'm using attribute, requires feature. And implementation of this attribute is like this. I'm using interception, method interception, to intercept stream HD video method. And if HD available is not defined on the active tenant, I will not let the code run into this method. It will automatically be stopped. So it's called declarative check. Or I can inject my feature checker. You can create a checker method here, and you can check is enabled like this. And it's called conditional check. You can also let your developers like this. And what you see in feature definitions, these are my features. I can easily render them on a UI, so I can let my users to change features in my multi-tenant application to configure. All my topics are now finished, but last I want to discuss you a little bit about multi-tenancy, because as we are running an open source repository, I'm getting lots of questions about multi-tenancy, if this is multi-tenant or not. Let's see some real-world examples that I get these questions from customers. So my customer says me, I have different branches in different cities. Is it multi-tenant? It's not multi-tenant. He's asking me like this. I have McDonald's in city center and McDonald's in train station, but Paul from finance department can control and see these two branches. It means Paul is a shared user in this system, and this is not multi-tenant application. Multi-tenant application means the data is isolated. Even it's in the same database, you cannot share this entity with any other tenant. Also, my university has different faculties. Is engineering faculty a different tenant? No, it's not different tenant. Each faculty, imagine you have a rector, he can see all the data in different faculties. So it's not, it's just, you are just grouping different entities. So I see especially people confuse grouping with resource sharing. Okay, let's see in this example. Imagine you have a website like Amazon.com. You have different shops, but different shops can share iPhone product. So it's also not multi-tenant because they are sharing product. In multi-tenant applications like this, will not share anything. In this implementation, Adidas and Nike will never share their products. They are different companies. They even will not want to see the shared data of each other. So Adidas shoes and Nike shoes in this implementation are totally multi-tenant. Another thing here, Amazon.com, there are different stores, but he is using a shared entity with Shop 2 and Shop 3. Shop 3 wants to leave the system. Again, it will break, and this is not multi-tenant. And lastly, sometimes banks, government agencies, in these special organizations, also multi-tenancy is not very good. They will not accept to be in the same database with other banks. Government agencies will not accept their citizen be located in London. They will not, because they have GDPR regulations, security precautions. Each tenant will have different database retention policies. So in these specific critical organization systems, multi-tenancy is not very friendly. I think we are running out of time. If you want to download this presentation, this is the QR code. My GitHub repository. I'm writing regularly articles on Medium. You can check. And this is ABP Frameworks website. It's open source, 12K stars on GitHub. All the things I have explained to you here from my experience in this framework. So thank you for listening to me. And if you have questions.
Thank you very much. I'm sorry we don't have enough time, but you can ask questions during in chat or back there. Thank you.
Okay, we are moving here. Thank you for listening to me.